responsive design. Just about ready to get started. Let's try this lunch. My name is Jesse Wilson. I'm an engineer on the cache team at Square. And I have the luxury of currently not writing Android applications. I'm working with a server. But that means that I've been working with a server for about a year now. And prior to that, it was about mobile. So I feel like I've got this both sides of the universe finally that I understand. And so I have appropriate amounts of sympathy and disgust for the server guys finally. HTTP is ubiquitous, and this is actually kind of annoying to me because I've been going to sessions all day, and everybody's talking about how to make HTTP work better, and they're still doing all the content for this talk. So I'm going to talk about all the things you might have already heard about HTTP. There's just so many important things to do to get it right. And because it's the protocol that we use for our applications to talk to the world, you really want to do it as efficiently as possible. You want to do it, be conscious of everything. And we live in this hostile world where everybody is working against us. We're working against the device has a small battery. The 3Gs, the data you have to pay for it. The government is spying on you. Hackers are hacking you. Your users are screwing up, and everything is just making it really hard. So, although HTTP is ubiquitous, bandwidth is scarce, batteries are small, and data is valuable. And this is valuable in sort of all senses of the word. It's valuable in that it's valuable to the users who have it, but it's actually much worse than that it's valuable to your enemies. So we have cases where I've got my data and somebody else wants to steal it. So I'm going to start and talk about making HTTP work well when the network uses Cubic sandwich. So one really obvious easy win on this is just download the right content at the right time. You're doing a contacts application or a photo application. You want to load the photos that the customer's going to see, but not the ones that they're not going to see. And so it requires you to be a little bit clever and do a little bit of work. But if you're intelligent enough, it doesn't take a ton of work. You just need a reasonable heuristic. We're showing a screen of contacts, it scrolls, let's load the next screen or the next couple screens. So that the user scrolls, the images are already ready for them. But let's not download the entire list because users will that bandwidth is wasted. Those bytes are dead. There's also a tool called Thumbor. Thumbor is this just geniusly simple server that you can install on an S3 box or in your cloud. It's a Python application, and what it does is it resizes images on the server for you. So you say your users are uploading contact photos, for example. In cache, we upload 1,000 by 1,000 profile pictures so you can have your face in the thing. But you don't want to send 1,000 by 1,000 pictures to the device when we're doing a thumbnail. We want to have our cake and eat it too. We want to upload these great big pictures, but we want to have these really fast downloads. And so Thumbor, just brilliant, easy tool. You say, Thumbor, here's the URL for my 1,000 by 1,000. give me a URL for 100 by 100. Very little configuration, it caches everything. And so if you're doing images, you should be using more. And this is like to win in terms of making your HTTP code faster, is just to download less stuff and to download smaller stuff. In the same sense, gzip is like such an easy win. You just go talk to your server guys and say, let's gzip all the things. They go in and write like a servlet filter or an interceptor or something. And then all of a sudden, you just get great size improvements. So instead of downloading 100 kilobytes of JSON, you download 10 kilobytes of JSON or 30 kilobytes of JSON. It's a big win. When we were playing with Square Wallet, we were experimenting with like JSON versus protocol buffers, and it was like this big motivation to say, let's switch from JSON to Protos. JSON to Protos, because Protos are like, it's a binary protocol. It's like massively compact. But it turns out that if you gzip the JSON and you gzip the protocol buffers, you get so much win by gzipping that the difference between Protos and JSON is just negligible. So just gzip all the things. The obvious counterexample is don't gzip compressed resources, like don't gzip JPEGs or anything, because then you're compressing compressed content and that doesn't work. Other easiest obvious thing that you just go talk to your server guys. You can like say, we made our application way faster because I asked the server guys to add some cache headers. There's built-in caching in OKHTTP, which is the HTTP client I maintain, and there's also caching in Android's HTTP URL connection, which builds on OKHTTP. The most important bit is just, it's like 2 lines of code to turn it on, and all the configuration lives in the server. So if your server says, like this resource is cacheable, it will be cached, and you don't have to worry about it. You don't have to like tag your certain downloads as put this one in the cache, don't put this one in the cache. I put 50 megabytes here, and what I'm trying to do is just give you like a sense for what is a reasonable value to put your cache at. Your device's data, SD storage is like pretty much extremely cheap. 50 megabytes is like, quarter, 25 cents, some really small amount of money worth of data. And the corresponding amount of bandwidth that you save is expensive. So this is like doing your users a favor. You say, let's make a 50 megabyte cache. It could be larger, it could be smaller, but I think like, I want to give you guys some really concrete advice, and this seems like a good place to start. When you're doing caching and you're talking to your server guys, there's really just a very simple way to look at the world. There's kind of 2 kinds of resources. When you do, when you request a resource that like is always give me the latest, give me the latest list of payments in Square Cache, or give me the latest status updates, then those things generally don't cache, and so you ask for a cache header like max age equals 0, and this actually will cache. What this means is that this resource expires after 0 seconds. But what will happen is the server's going to set a max age, and the device is going to keep a track of that image and when it downloaded it. And when you ask for that same thing again, you just say like, give me my latest tweets. Instead of saying to the server, give me my latest tweets, it's going to say, give me my latest tweets, and this is the last time I checked. It's conditional caching, and so you can basically get your cake and eat it too. You can cache resources without having to worry about staleness. Conditional get's like amazing, easy technology that you don't have to do anything to do. You get it for free, as long as you can convince your server team to spend like 20 minutes and turn it on. The other type of asset requires a little bit more structure to how you think about your program. Cache control equals max age and then some really low number. In this case, this is the number of seconds in the year. And what this is like, when you have a resource that's immutable, give it a unique URL, like generate a random number or generate a random token. Give it a unique URL and say this in cache form. And so if we're doing profile pictures again, I upload my profile picture, it gets the URL 1234. I decide to change my profile picture, it gets a different URL, and both of those can be cached forever. So this is like a really easy way to cut the world up. Last one is the Content Delivery Network, CDNs. That's where we're currently using CloudFront from Amazon. It's easy. It lets you defeat the speed of light. And what I mean by that, I got a cute little ugly table here, is that when your application is making requests to the world, and your application is in New York, it's really convenient if the resources it's downloading are in New York or on the East Coast. Similarly, people on the West Coast want to be getting their resources from the West Coast data center. So when you use a CDN, CDNs automatically distribute things geographically for you. You don't have to worry about it. You don't have to set up multiple data centers. And so you get this wonderful behavior. On this diagram, it's a little hard to tell. iOS is doing something awesome, which is that on the West Coast, which is the left side of the chart, resources served from the West Coast data centers are faster. And on the East Coast, resources served from the East Coast data centers are faster. And Android is screwing up, and they're always the same speed. And that's because Android currently doesn't do anything intelligent about picking which data center it goes to. That's a bug I have to fix. When that happens, we'll all rejoice and we'll have slightly lower latency. This is what happens if you don't use a CDN, basically. So moving on, I got a brief talk about making resources better. And this one, it's what happens when your network disappears. So there's basically, your application is going to have to deal with flaky networks. And flaky networks are a fact of life. We get Wi-Fi on planes now, unfortunately. But the network is always going to be coming off and on. You're going to be riding on subway, you're going to have your network is going to go up. And so making it so that your application is completely reasonable when the network is flaky is just a way to write high quality code. I recommend, again, to be concrete, set 10-second timeouts on things and adjust to taste. So if you set 10-second timeouts all across your stack, and certain requests fail because your servers are taking 11 seconds for certain requests or something, then you adjust that, and you can do it at a relatively granular basis. Next thing is to make sure that your application responds when things fail. And this is something that isn't in the HTTP stack. This is in your application and it's in your design. So when you're building your application, here's an example of the Square Cache activity screen. And what happens when my network fails and I want to view my history with map? I click on it, it attempts to load, and it says, couldn't load, try again. It's absolutely awful when I'm in some application and it says, couldn't load, and I've got no action to do to tell it to try again. This is nice, just tap the button, it'll attempt to load it again. I know that my network is down. This is really easy to build if you think about it. Slightly more sophisticated behavior is for your application to detect when the network is going away, coming back. But for the most part, just giving the users an option to try again is sufficient. And you mostly just want to put this in your application. All of your screens should have data is loading look, a data is loaded look, and a data failed to load look. Pretty straightforward stuff if you do the work. And the last one is really important and really hard. The Gmail application on Android is completely wonderful because I never ever have to worry about the network when I'm in Gmail. It has local database. All my email is local. I can send mail, I can read mail, I can even search mail offline. And I don't have to think about what's happening behind the scenes. Gmail is just magically syncing, and the data on my device and the data on the cloud are effectively the same. And I don't have to think about the partition. So if you're building an application that people are going to use, you really want to have, people are going to use your sense, but you're going to want to have a local database where you have a copy of the data and you sync between the server and the cloud. This is a ton of work. It's really hard. You have to make sure you have versioning protocols and conflict resolution things. If you just have a local database that has a local copy and it's read-only, very simple, easy win. This just basically makes your application work really fast and work really nicely and survive network flakiness. And it avoids a whole bunch of weird anti-pattern bugs. The one that's been bothering me a lot lately is you get a notification in your notification bar. It says something, very important, click here. And I'm okay, tap. And then I get the progress bar. And it's just really annoying that the application is hey you, I want your attention. And I give it my attention and it's I'm not ready yet. it asked me, it should have had that ready. And building a local database just makes that type of flow easy. The last one is when your device's battery, you want to be conservative in terms of the device's battery, and most of the time, if you're conservative with the network, you get the battery for free. This is like one of these great things about performance. Is that like, if you optimize code, it uses less CPU, it uses less battery, it uses less radio. The most important thing to think about with the battery is that the radio comes up and the radio goes down. And when the radio comes up, it spends a lot of battery to boot up the radio. And it stays alive for a while. And so, generally, the smartest thing to do with the battery is to do your syncing jobs when the radio is already on. So if your device is already talking to Wi-Fi, you want to do your syncing jobs right then and there when you're on the Wi-Fi. And this is really easy. There's an API for it. It's called set inexact repeat. And the inexact means when the radio is on, this is when you do your work. So the alternative is set exact repeating, and I think it's like you don't need to sync exactly every 15 minutes. You just want to sync approximately every 15 minutes or approximately every day. And so the inexact API just means that it bundles your code when the radio's already running. All right, so this stuff so far, pretty straightforward. And now I get like tinfoil happy and preachy. So our industry grew up on this like old internet where like it was like a hello world internet that just turned into the real internet that we know and love. You know, we didn't like design an internet for attackers. That was bolted on. You know, like the internet security model of 1970 and even like 1998 is pretty much everybody online is trusted, and this just is not the case anymore. So we've gone through this like awakening where we're realizing just how stupid we've been with security. The network uses HTTP, and there are so many bad consequences of it. Everything you send is in the clear, and so in the 90s, we said, well, we're going to solve this problem. We're going to take our secrets, which are our credit card numbers and our passwords, and we're going to make sure that SSL is enabled whenever we send those things out on the network. And so you do something like you go to Gmail, you sign in, and it would use an SSL when you type your password in, and then it would return you a cookie that is a session. And anybody who has that cookie also has your session. The cookie is just like, here's Jesse. You can do everything you want to do as Jesse with this session cookie, and it lasts for a day. And so the model of like, we turn on HTTPS when we do sensitive things or when we're sending passwords over the wire, it's completely broken. But even if it weren't that cookie, there's still the problem that the stuff I want to protect, the password is a password. But the email that I'm doing, that's actually the sensitive stuff, right? Like when I'm saying, I'm sending these emails and I'm saying like, I don't know, 2 years ago, it's like, I'm quitting my job, I'm going to go to another company. That's like extremely sensitive, that's really private. Another thing is that like, your photos. There's been recent disasters around how people's private data has been like, basically stolen by, I think, sex offenders. And it's just like, why? Because security is hard when people aren't doing it properly. So the last one I wanted to talk about on this is just like every single type of data that you have, you pretty much want to use crypto. There's a bug recently in Maven Central, which is where we're now running all of our jar files. And thankfully, some attackers can fix this. But until recently, you would say, like Maven install, and it would do its thing where it downloads the internet so that it has a full copy of all your jar files. But all those downloads were happening without security. And so what was possible, I don't know if this has happened, what was definitely possible is that somebody could say, here's a hacked version of WAPA, and if you attempt to download WAPA through an insecure connection, we're going to give you this hacked version instead. And what's the difference? Maybe it reports anonymous data somewhere. Very, very easy to put like very, very bad things in code. So basically, if you've ever downloaded code on an insecure connection, you're vulnerable. So you want to make sure your stuff is all secure. If you don't, you get all this code, it's not working correctly, and you have problems. Next slide. All right, so security is really important. Another example of where you want to make sure things are working really well is when you're doing like ads injection. You're doing an HTTP request to your server, and it's plain text, and Comcast is adding a service where they're going to say, let's add ads for Comcast inside of the HTTP requests for whatever websites you're doing. You know, you're doing like a news site through a Comcast network, and it's saying like, you probably want a Comcast ad here. We're a great company, we're going to add features for you. So if you use HTTP, you're basically vulnerable to well-meaning and misguided organizations everywhere between where your device is and where your service is. Also, Firesheet exists. Does anybody use Firesheet? This is a great app. You get Firesheet, you go to Starbucks, you turn it on, and you just basically get to see all the HTTP traffic of all the other people at Starbucks. And this is like, we think about it a lot with web browsers, but the same is also true with our apps. So the advice is just use HTTPS for everything. Yes, everything. And I feel so strongly about this that I'm tempted to like add bugs to the HTTP client so that it breaks if you don't use HTTPS. Like I really feel everything HTTPS. This is the main takeaway from the whole talk. De-discipline use HTTPS. So just like hammering it home. All right, and the last bit is that HTTPS is great. It protects you from hackers, and it protects you from bugs, and it protects you from your privacy, it protects you from rogue advertisers. But we're also in this like weird dystopian cyberpunk era where even like the people who are on our side are doing weird things with our network data. We know Edward Snowden, he basically unveiled just the scope of how much data the NSA was spying on. Here's an article that says, so that's the US. Iranian man-in-the-middle attack against Google demonstrates dangerous weakness of certificate authorities. So the certificate authority is the company that says your HTTPS identity is Square, your HTTPS identity is Twitter, your HTTPS identity is Facebook. They hand out certificates. And the problem is that a rogue certificate authority was compromised by the Iranian government. And they said, Iranian government, yeah, you can also be Google. And so what happened is people would do their Gmail in Iran, and the government had access to that. And so if you're doing things that are private, if you're a dissident, or even if just the government has interest in you, the certificates that were supposed to protect you were not working. And that's because certificate authorities are incredibly bad at their jobs. They're just like, we've given them a hard job to do, which is never leave the trust. And that they violate it. And they violate it because there's dozens of certificate authorities, and you only have to compromise one of them to get what you want. So the workaround for this is a technology called certificate pinning. And what this does is instead of trusting VeriSign to say, yeah, Square certificate is Square, you trust yourself. You generate a certificate, you sign it, and your device knows, I only talk to Square certificate that I know is run by Square. It's a little bit of a hassle, but it's pretty much the only way to defeat the incompetence of the certificate authority system. Another one that's tied into this is that we're sending all this data from our applications to our servers. And one thing that makes it really hard is that because this data has so much value, there's a lot of people who are interested in it. So Lavabit was this secure email provider run by a guy named LeVar Levinson. He was not making like a ton of cash on this, but it was like this sort of like build security guy. And so he built this email service. And the idea of Lavabit was your email is secure, and only the people who have access to their accounts have access to their accounts. But because of like crappy ways that webmail works, and crappy ways that the trust has to be on their servers. The Lava-Bit email service was only like secure as far as it was only secure as far as them promising. And so the NSA said, you know, hey guys, we know that there's a guy named Edward Snowden using your service, and we want to read all his email. And so Lava-Bit had this problem, which is that they had all this data that wasn't theirs. It was their customers. And then they had the NSA say, basically, like, we want this data. And although, like, we can all say that the NSA is pretty reasonable, we don't necessarily know that's the case for all of the governments in the whole world. So generally, the thing we really want to do when we're building our HTTP stacks is be, like, really disciplined about what data we're collecting. The thing I want to say is, like, hackers can't steal data you don't store, governments can't eavesdrop on data you don't send, and bugs can't leak from data you don't have. We've seen all these situations where you've got a server and it just has, like, way too much important sensitive data, and that data can leak, right? Like, you're building a photo management site, suddenly you're a target because all those photos are extremely interesting. And so the advice I give you is that when you're talking to your product team and they say, we've got this really great new social feature, and what we're going to do is have your app upload the address book with all the contacts, upload all the photos, back up all this stuff. I just recommend as an engineer, your job is mostly to push back and say, I don't want our team to be responsible for holding this data. This data is like, it's like a time bomb, waiting for somebody to come in and take it, or us to have a bug and leak it. Just push back, saying we don't want the responsibility of having this data. It makes it makes us sleep much better at night if you don't have to worry that a hacker who breaks into your system has access to all of your customers' data. Here's an example of how we do this in cache. We had this our designers had this great idea for a new social feature in cache. Cool feature. We want to tell you, here's everybody in your device's address book. And we want to give little green uses cache icons to the people who are using cache. And so we have this, like, security problem, which is you don't really want to upload the address book of the user to the server, so the server can say, these are the 13 people here who use cache. And our server can't reasonably send its data down to the device and say, here are the people who use cache. So we have this standstill, right? How do we get the knowledge that Alan Wilson uses cache, and Alex Chow uses cache, and Alan Wilson does not? Hard problem. So it turns out that you can just use crypto for these types of things. Instead of sending to the server Alex Chow's phone number, we take Alex Chow's phone number, we hash it into complete garbage. Alex takes his phone number, he hashes it into complete garbage. We both send it to the server, and the server looks for matches. So it says, oh, you've got this address, you've got this hash. That means that's somebody who probably uses cache. So our server doesn't need to worry about having Alex's phone number, or even necessarily having a relationship between this phone number and this name for people that aren't using the system. Really, like, easy feature to implement when you think through how to do it, and a system where basically we need to be sure that we're all guarding our users' data. So, next thing I want to talk about is a little less, like, scary or sketchy. When you're building your application, you have to worry about what happens when the server guys screw up and your application crashes. This is like the completely delightful 404 page for Square Cache. You need to make sure that if the server is broken or the server is unreachable, your application works. And so pretty much the only defensible way to do this is idle moments. In Square Cache, we want to send our friend $50. And if the network hiccups, we want to retry sending our friend $50. And what we never ever want to have happen is to send our friend $100. That's, like, really sketchy and bad. And so how do we do that? Idle moments. Simple technology. You can make it as many times as you want and it works. There's a bug in OKHTTP where if you attempt a request and it fails, it can retry it, and it may retry it automatically. And there are people who are like basically saying, we're using OKHTTP, and our customers are accidentally sending $100 instead of $50. And the fact is that like we don't actually have a good solution to this, because if you're using a network stack and it crashes, we can't tell if it crashed before anything happened or if it crashed after the request went to the server. So if you make everything idempotent, both class and problems go away. And it just like makes reasoning about the program much easier. Another thing that makes this type of problem easier is a library from Square called tape. And what tape is it's a job queue that's persistent on disk. When Square registers that device that you swipe a credit card, we capture information from the credit card, encrypt it, and then we send it to our server to process the payment. What we really want to not have happen is swipe the card, customer leaves, application crashes, and the money is missed, right? So we've got this program called tape, and the way it works is you just write jobs to a queue. You say, this transaction needs to be sent to the server. And when you use tape, you say, run this transaction to the server, you call it, it runs, everything's simple. Really easy library. If you're doing anything where you want to avoid retry complexity, just get tape. Another one with the servers is you have to worry about response codes. You send a request to the server, it sends back 200, you're happy. You have some agreement with your server team that when things succeed, you get 200, when things fail, you get 400. It turns out that you pretty much always have to handle all the response codes, even if your server and your client never speak of those response codes. And the reason is that generally there's going to be middle boxes between your device and your service. So, for example, you might have a load balancer, and the load balancer might say, your server is currently being restarted, and I'm going to return 503 error. And although your server never even saw that request, your device needs to handle it. And one consequence of those middle boxes is that anytime you get a response code you're not expecting, you can't assume that that response came from your own server. You can assume it came from a middle box or a load balancer or some proxy. And so that means you have to be really careful about parsing responses that you weren't expecting. Next one, really valuable and important, is when things don't work, you have to tell somebody about them so that those things can get fixed. When you make your call to the server and you say, create this payment, and the server says, not found. What you absolutely should do is say, I got a not found exception. That means the client, the Android application is broken, and you need to report that to Crash Predicts or Bug Command. And that way, you can detect that there are bugs. The server folks aren't actually going to see this because they're going to say, oh, 404 not found. That means that somebody, some hackers are playing with our system or something. The only way to do it is for the client who made the mistake or whatever, detected the problem, to report it to another service. This has been extremely valuable for cache. We report what's broken, we fix it, it's great. Another one that's making the world hostile for us as Android developers is that the clients are pretty glitchy. In particular, HTTP route connection, a library I used to maintain, just different bugs for different versions of Android. It's a pain. And Apache HTTP client has this frozen API where basically it hasn't been updated, and all of the bug fixes that they've done upstream aren't available in Android. So the solution to this problem is a library called OKHTTP. It's a really reasonable HTTP library. You also get the benefit of a much nicer API. So here's an example. Asynchronous request. You have a builder for the request. You create a call on the client. A call is this thing that encapsulates a request at a time. I would say the request is abstract. The call is very concrete. And they say execute the call. That happens synchronously, and I get a response back, and I can take my response and do stuff with it. Things like getting the response body as a string. It's quick and dirty and extremely convenient. If you've got a long response, you don't want to do this. But all the other libraries give you an input stream, and then you have to like fight the world in order to figure out what the char set is, and then decode it and use readers, and you end up with like tons of code. The other thing that's nice about OKHP is that it works in both this synchronous mode and an asynchronous mode. So we take that, we just rearrange things, and so this is how it works asynchronously. Instead of calling execute, you call enqueue, and you get non-response callback. So very much the same thing. One other thing that's really nice about this approach is that OKHTTP can manage how many requests are currently in flight on the server at a time. So if you load an application screen and it says, I have 30 different images to show, you don't really want to spawn 30 different threads and make 30 different simultaneous requests. With OKHTTP doing the threading, it can manage how big that queue is. If you do use OKHTTP, I recommend you read, we've got this doc called recipes. We spent a lot of time on it. It's just examples of how to do everything. You can cut and paste them. And we're really proud of this documentation. So that's like the low-level API. But we're busy, and so there's higher-level things. When you're doing REST, it's exhausting. You've got a lot of work to do. Make a call to the server, save some data, load some data. You've got to marshal the request object, add your headers, send it out to the server, get the response back, parse it, and then worry about errors and do all this work. So Square's got another library called Retrofit, just completely brilliant API. You write an interface that describes what your server does. Retrofit does the work. And if you are not using Retrofit, you should. And since you shouldn't be using Retrofit, you may also want to go see the talk. There's a talk today at 4 p.m. upstairs explaining how Retrofit works. Another basic, high-level problem we run into with HTTP is that image downloading is painful. There's just again, a whole bunch of work you need to do. You have to worry about creating background threads, creating buffers, decoding the bitmap or sampling the bitmap. And then there's just weird performance issues, like do we reuse the buffers, things like that. So Square's got yet another library called Picasso. Brilliant library, also really easy to use. You just say, this view gets this image, and the image is just a URL. Really easy, and it'll do tons of nice things, and it can integrate it with more. So you say, to take this 1,000 by 1,000 image, put it in this 50 by 50 image view, and Picasso can take care of making thumb board or resizer. More things that cause us pain. Testing in the network is awful. So when you're working, you have to, I hate it when we're like, okay, hey server guys, I want to test this API. Is the server up? It doesn't work. The server's always being rebooted, something like that. So the way we do it at Square is we build mock mode into our applications. This is we get Retrofit to give us interfaces, and then mock mode means we can have really easy to write implementations of those interfaces. In Cache, our application has this really cute debug drawer. Slide it open, and there's a little mock mode endpoint. So you can say, run this app, toggle it between talking to a production server or talking to mock mode. Just makes us so much productive. You can get this thing from the U2020 library. Really easy. Put this in your application, and you'll find tons of reasons to shove buttons in here that make development easy. And just automate the tests. You guys saw the Demetrius talk. Testing so valuable, and if you don't automate it, it's just so much work. So one other thing along the lines of testing is that OpenHTTP has this project inside of it called mock server. It makes it easy to say what happens when the server responds with this type of crash, or when the server responds like this. It lets you do a closer level integration testing. Last bit is that the network is invisible. You're writing all this code, you're sending things to the server, you're sending things back, and it's really hard to get a grasp for what's actually happening. So what I recommend is if there's this application called Charles Proxy. Charles just sits between your application and your server, and it shows you all of the back and forth. It's a lot easier than Wireshark. It knows how to speak HTTP and do things like the code protocol buffers and the code JSON, so you can see everything exactly as it's supposed to be. In this case, we can see exactly which requests are made. And if you run this, you're going to realize, like, oh, we're being dumb. We're sending this header twice. Oh, we're being dumb. We're making this request more times than we want. Why is this request working? Or even things like, hey, the server, like, are the cache controls happening? Cache control headers happening? And the server guys are like, yeah. And then you can go and make sure that they're actually being honest. So, I actually more unmaintainable web APIs. So, basically, building these APIs is hard, right? We're designing this like sophisticated protocol where you've got all this data on the device, you've got all this data on the server, and you want to make sure that these two things keep in sync. And there's like a granularity problem, especially because every request has a little bit of overhead. Here's an example. And again, in cache, we have a list of payments, and every payment has an amount, a sender, and a recipient. And the sender and recipient is a customer. And so, very quickly, in order to get like a list of 10 payments, we end up getting like a lot of data. So we have like a whole bunch of payments, and every payment has customers. And so, one issue is like, how do we download that set of entities in a way that's reasonable? One way would be you make one request, and it just says, here's everything. That works well, except when only one of these payments has changed, and then you have to get the whole world again when you want to see what's new. Another model is that you get the list of payment IDs, you get the payments, you get the list of customer IDs, you get the customers. This is like extremely highly granular, and until recently it's been basically untenable because of the number of round trips to the server. But technologies called Speedy and HTTP2 are really trying to solve this problem. The main point of these two technologies is that they lower the overhead of making server calls. So instead of having one request at a time on the socket, you get Speedy and HTTP2, and you can say, like, server, give me all these, like, 10 different requests for 10 different customers. It interleaves them, and you get them all together. And suddenly, you don't have to worry so much about structuring your APIs in a way where the amount of round trips is managed. So that's it. That was a little bit of a whirlwind. I want to just walk through again my takeaways. Talk to your server team, tell them to add the cache headers, tell them to turn GZIP on. Hook up bug reporting, like get it so that if something fails, you make a 404, you get a 500. It lands in crash lytics or bugsnag so that you can follow up on it and fix it. Get all the Squirt libraries, they're really good. And try Charles, which is this thing that it's the server that lets you see exactly what's happening. That's it.